The James Webb Space Telescope, likewise known as JWST or simply Webb, is a pioneering instrument that has uncovered astonishing insights concerning stars, planets, galaxies, and other intriguing astronomical phenomena. It is setting new standards for scientific exploration and is hailed as the admired successor to the Hubble Space Telescope. People from around the world are exchanging photographs or utilizing raw data to create new insights. 1 year has passed since the impressive James Webb Space Telescope revealed its first ever noteworthy image of the universe, stunning astronomers across the globe with its exceptional detail. However, its latest findings have presented a frightening image of the universe that we have never seen before. What has been discovered so far by the James Webb Space Telescope is raising more questions than it answers for researchers. Join us as we explore how the James Webb Space Telescope has captured some of the most extraordinary images in history. Just 1 month after its initial photographs were released, the telescope disclosed new data about star formation, system formation, and the early universe. The pictures were remarkable, revealing the universe in unprecedented detail. Since then, the number of discoveries has soared, providing researchers with a treasure trove of data. The James Webb Space Telescope's observations of incredible phenomena, such as the Tarantula Nebula, record-breaking space clouds, stars on the brink of supernova explosions, and other extraordinary celestial objects, have been reported. This satellite observatory's cutting-edge technology allows us to peer deeper into space than ever before, uncovering previously unknown insights about the universe. In its first year of operation, NASA released a stunning image showcasing a small star-forming region in the Carina Nebula. The image reveals jets emitting from infant stars, surrounded by vast clouds of dust in various colors. Molecular hydrogen makes up the red dust, and the presence of a circumstellar disk raises questions about potential planet formation in the distant past. Although this image depicts cosmic chaos, NASA notes that this stellar nursery is relatively small and calm compared to others. Many of the young stars in this region are about the size of our Sun or even smaller. This image was captured by the main camera of the observatory, the near-infrared camera, NIRCam, which captures expansive images in 2 distinct infrared ranges simultaneously. Moreover, the Space Telescope has enhanced our understanding of exoplanets, planets that orbit stars other than our Sun. The James Webb Space Telescope excels at observing distant galaxies and was able to identify its first exoplanet, LHS 475b, at the beginning of 2023. This planet is located 41 light-years away and has a size comparable to Earth. According to NASA, James Webb is the only operational telescope capable of analyzing the atmospheres of Earth-sized exoplanets. Following that, the James Webb Telescope found evidence of ancient galaxies that, theoretically, shouldn't have existed. Dr. Eva S. N. of Penn State University and his team discovered 6 colossal ancient galaxies, termed galaxy breakers, which could fundamentally change our understanding of space. These massive galaxies may have formed between 500 to 700 million years after the Big Bang, according to the researchers. Recently, the telescope's infrared sensors identified them, allowing us to look back in time around 13.5 billion years when stars and galaxies were much younger. The immense scale of these galaxy breakers has left researchers astonished. Galaxies in the early universe were expected to be 10 to 100 times smaller, but observations suggest that these 6 objects could be billions of times more massive than our Sun. The combined mass of all the stars in one galaxy might be 100 billion times heavier than our Sun. Does the prospect of trying to comprehend something so vast give you the creeps? While most galaxies during this period are relatively small and still forming, some giants seem to mature much more rapidly. The reasons behind this phenomenon remain unclear. Joel Leha, an assistant professor of cosmology and astronomy at Penn State University and a co-author of the study, expressed his awe at the discovery of a new class of objects formed at the beginning of the universe. The finding that the development of massive galaxies began at the universe's earliest moments challenges many of our previously held beliefs about cosmic evolution. It seems that these discoveries are so unexpected that they present challenges to the scientific community, throwing into doubt our entire understanding of how galaxies formed in the early universe. Many of these galaxies are considered infants as they are still in the process of formation. However, galaxies as old as our own have been found in the early universe, which was previously thought to have emerged much later. Spectrometry, which separates light into its component frequencies to enable more precise distance measurements, is still required to validate these results. This has researchers scratching their heads, as there are only a handful of recently discovered objects for which distance and mass have been confirmed. If the data is accurate, galaxy formation must have been significantly more efficient and rapid than currently believed. The fact that spectra have substantiated our existing models based on visual observations is promising. For years, researchers have sought to interpret cosmic history, and a single piece of equipment might hold the key. Observations from telescopes have long piqued the interest of scientists, so it's not surprising that conflicting data from telescopes could lead to current uncertainties. Cosmologist Dr. Katie Mack has shared her insights on this matter, emphasizing how the JWST has been providing evidence of galaxies that seem to have begun or evolved much sooner than what researchers had anticipated from their models. So, while there are many exciting discoveries on the horizon, there is also much work to be done in unraveling the mysteries of our universe. The telescope is catching pictures of universes more than 13 billion light-years away, and they are, to some degree, foggy. It seems like there hasn't even been enough time since the enormous detonation for these large worlds to have formed by the dates that cosmologists have been observing. Numerous experts in the field are worried that this casts uncertainty on different hypotheses, including dark matter and the Big Bang. However, we ought to go further into the evidence to find out. Without a doubt, the telescope captures stunning views of nearby nebulae, but fluffy little specks when it comes to faraway galaxies. The reason is that various colors are impacted by different parts of the light spectrum. The Webb telescope can detect light from a source in two distinct ways. It may use a spectrograph to spread out the light, which works a bit like a prism, examining the brilliance of each color, or it can utilize filters that block everything except a select range of colors. They can then compute the redshift of the universe by contrasting this data with spectra predicted for galaxies with the same characteristics. What this redshift illuminates for us is the specific moment in cosmic history that we are observing. It turns out that numerous galaxies have an abundance of stars, or stars that were too young when they would have lived, as indicated by examinations of model spectra. There are various possible explanations for this. The photometric readings could have been off due to issues with the telescope's alignment. Alternatively, they might have been observing a group of galaxies that isn't representative of the standard, or it could be an incredibly small region of the sky. Another possible explanation is that galaxy range models are designed for closer galaxies, which don't work well with galaxies further away. Cosmologists would face the exciting possibility of having to completely reevaluate cosmic evolution if those galaxies are indeed very large, and prior assessments were mistaken. Yet it's hardly the only area where researchers have missed the mark. Despite technological advances, planets that are entirely too large to exist have scientists baffled, especially with the discovery of a planet considered too massive for its star. This has prompted a reassessment of our understanding of planet formation and nearby planetary system architecture, as well as the models developed by astronomers. In the latest research from Penn State, rumors suggest that this planet is in a planetary system around the ultra-cool star LHS 354, a star that is multiple times less massive than our Sun. According to a news statement, the small star has a mass ratio multiple times higher than Earth's ratio to the Sun. Until recently, researchers didn't really believe that such a situation was attainable, yet new evidence shows that the largest planet in our nearby planetary system is indeed orbiting one of the universe's smallest and coolest stars. We still have very little insight into the universe, and this finding demonstrates it even more. A planet of this mass orbiting a star with such a low mass contradicts our expectations. These stars might have formed in massive gas and dust clouds, and planets might emerge from the gas and dust that remains in the disk of material around the infant star. However, it isn't expected that the planet-forming disk surrounding the low-mass star LHS 30154 contains enough solid mass to produce this planet. Still, it exists, and we must now reevaluate our hypotheses concerning planetary development. A good analogy would be to compare the star to a campfire. In order to maintain your internal temperature, you need to get closer to the fire as its temperature diminishes. Planets that need to be sufficiently hot to support liquid water should be nearer to stars with lower temperatures. If a planet is in a tight enough orbit around an ultracool star, we can see the pull of the planet on the star's light or spectra, which causes a slight change in the star's color. Meanwhile, looking up into the sky, a new stunning picture of the ice giant Uranus, highlighting virtually its dusty rings, has been snapped by the James Webb Space Telescope. The fainter rings, which had previously been hard to photograph, were only seen by the Voyager 2 and W.M. Keck Observatory on Mauna Kea in Hawaii. The image is a stunning demonstration of the telescope's responsiveness. Uranus, which is 1.12 billion miles from the Sun, has 13 recognized rings, 11 of which are displayed in this amazing new picture from the Webb Space Telescope. Unlike Saturn's even rings, this planet's unconventional side tilt causes its rings to appear vertical. The two outer rings were not recognized until the 1986 flyby of Voyager 2 because their dusty composition made them less apparent and harder to photograph. The 9 major rings were already known before, and in 2007, photographs taken by the NASA Hubble Space Telescope revealed 2 more fainter outer rings that are not visible in the Webb photos. The Webb has the potential to find them, according to researchers. A planet's ring system provides valuable information regarding the planet's origin and history. Uranus is an incredibly unique globe with its tilted orbit and lack of internal heat, so any data regarding its past would be highly valued. The unconventional atmospheric composition of the massive gas giant Uranus is something that scientists are hoping the telescope can shed light on, since no other telescope of this scale has ever been able to see infrared light. The JWST allows us to analyze Neptune and Uranus through a heavenly novel lens. Telescopes that utilize visible light, like Hubble, cannot observe infrared frequencies. However, infrared imaging can reveal previously subtle depths and dynamics. Additionally, remarkable footage of a star nearing its death has been captured by the James Webb Space Telescope. In late 2021, the JWST sent back the blurred star image, which is among the first perfectly recorded instances of its kind. The colossal dying star Wolf-Rayet 14 was caught on film by the telescope's infrared lens as it ejected gas and dust into space. It is believed that this celestial event is happening 15,000 light-years from our planet. The image, provided solely by NASA, shows a glowing purple remnant of the star's core, which was previously a faint veil of dust and gas causing the star to erupt. This staggering image is an enhancement of one that the Hubble Space Telescope captured a few years ago in 2015, before the JWST was launched. The Hubble Space Telescope appeared to be more like a bursting ball, however, our technology couldn't capture the finer details. The destruction caused by Wolf-R 124 is now clearly apparent. It is believed that the massive star, which is located in the constellation Sagittarius, is multiple times greater than our Sun. Additionally, it has expelled enough gas and dust to cover at least 10 suns. According to NASA, there is a star at the center of this stunning new image. For the past 15,000 years, that star's light has been traveling across the universe. It will take 15,000 light-years for it to reach the telescope's detectors. What appears to be dust around the middle star is indeed dust. When a star dies, it sheds its outer layers and material into space. As seen in the outline, planets will form from this dust as it disperses into space. This is actually how we arrived here. Scientists believe that a star in the process of shedding material is on the verge of detonating, a phenomenon often known as a cosmic explosion. Although the breakdown of Wolf-R 124 will be undetectable to the naked eye, 5 planets will be visible from Earth. Interestingly, a genuine beast in space had its look captured by the James Webb Space Telescope. This spooky, ghostly entity was seen by JWST as it prowled through space. In fact, a galaxy produces many new stars every year, not some enormous extraterrestrial being. The galaxy, which has the designation Aztec 71, was initially discovered nearly a decade ago by a ground-based telescope. However, when the more refined Hubble Space Telescope analyzed it, it seemed to vanish. With the help of the James Webb Space Telescope, this long silent galaxy has now made a victorious return to the universe. Aztec 71 appears as though it's shouting into the void in a craftsman's depiction, which gives it the appearance of having two eyes and a door-like mouth. This finding modifies how researchers view the early universe and raises the possibility that colossal star nurseries were 3 to multiple times more common than previously thought. According to the team's computations, the redshift of the universe being observed is around 6, which places it at about 900 million years post-Big Bang. This massive entity is indeed responsible for the formation of many stars yearly. What truly excites us is that our newest telescope produces images so delicate that even something so dramatic is scarcely noticeable. A vast number of galaxies might be revealing themselves to us, as dust absorbs most of the starlight and re-emits it at redder, longer wavelengths. Dusty galaxies have proven challenging to photograph before this. Previously, our only method of observing galaxies in the early universe relied on the optical lens of the Hubble Space Telescope, as our eyes are limited to seeing dust-free worlds. Thus, our understanding of galaxy evolution has been skewed. The Hubble Space Telescope cannot detect the infrared characteristics that the NASA James Webb Space Telescope can. The JWST is sufficiently sensitive to look into the universe's furthest corners and even penetrate the thickest dust clouds, allowing us to analyze the optical and infrared attributes of this previously hidden collection of galaxies. The Universe Web project intends to catalog up to 1 million galaxies from an area of the sky the size of 3 full moons. Despite the observatory's reputation for gazing into space at the farthest possible distances, NASA has also used its advanced capabilities to make discoveries in our own backyard. Utilizing the detailed photos of Mars that JWST captured last year, researchers can examine more transient phenomena like dust storms, atmospheric conditions, and seasonal changes. However, the red planet presents a challenge for the powerful space telescope, as the infrared light from Mars is blinding to the onboard instruments due to the extremely bright conditions. Astronomers had to employ specific data analysis techniques and use very brief exposures to compensate. The specialists who made these discoveries assert that they will analyze the spectroscopic and imaging data to search for